So in part B of question 7, now we're told that the car travels at a constant speed up an inclined hill at an angle of this to the horizontal. We need to find the greatest possible speed of the car going up the hill. So to do this, I will draw this slope. This is again a typical slope problem over here. So we have angle theta here. We have our car over here. We have a engine force, some driving force, let's say Fe. We have the weight, and we will have the resistive force. So as usual with the ramp problems, we need to split everything into its components. So here we only have to break up the weight. So we will have a mg cosine theta for the vertical part and an mg sine theta for the horizontal part with respect to the ramp. And then what we can do now is write up the net forces, because we know A is equal to 0, so we're going at a constant speed. Therefore, the net forces will have to be cancelled out in every direction. We know that the resistive force is just 40 times the speed of our car. And then we can say that mg sine theta is just 1200 times 10 times 0.15. And this is 1800 newtons. And what we know now is that the total engine force that has to be exerted such that all the forces are balanced out. So the F net or the Fe is going to have to be equal to the forces that are pulling it back down. So the resistive force and the horizontal component of the weight. So 1800, which was the horizontal component of the weight, and then plus this resistive force of 40 times V. All right, and what we know is that the max power output of the car is 92,160, and this again is just force times velocity, and the net force is just 1800 plus 40 V, and we times this with V. So then we get 1800 V plus 40 V squared, and well, now we just have an equation for V. So we have V squared. I'll bring everything to one side. So we have 40 V squared plus 1800 minus 92,160 is equal to 0. And of course, you have the V over here as well. So, well, we can just use our calculator here. We could use the quadratic formula as well, but we will get one positive, one negative value for V. Obviously, the negative value doesn't make sense here. So we just say the positive solution is 30.5 meters per second, and therefore this is the answer.